This is Geometry, Section 1.3, Measuring Segments. So in the last section we learned what line segments are. Now in this section we're going to learn how to measure them and do different things with segments. So first we start off, we learned that the notation for segment AB is right here. So we use capital letters A and B and a line segment over them with no arrows. So in this diagram, since the length of segment AB is 4 centimeters, it's also common for us to see this. Just letters A and B in italics with no bar over it. That is equal to 4 centimeters. That basically just means I can either say AB or BA. So either one of these mean the same thing. In italics with no bar over it means that the length of that segment is whatever it says it's equal to. So this right here means that that segment is equal to 4 centimeters, or it's 4 centimeters long. So for example, fill in the blanks. This is pretty simple. So PT in italics, no bar, how long is that segment? Well, if we look at this diagram, it tells us that that segment is 17 inches. RP, it tells us that that segment is 8 inches. Now it's asking me which segment is 15 inches. Well, RT. And which segment is 20 inches? This isn't as straightforward, but if we look at this segment and this segment put together right here, this one is 15, this is 5, so if I add those up, I get 20, and that is segment RQ. So this leads us to something called a postulate. A postulate is kind of hard to define. We basically say that it is something so obvious that we accept it as true. So we can't really prove that it's true, but it's so obvious that we just say, all right, that's true, and move on. So the first postulate we're going to talk about is the segment addition postulate, which is kind of what I described up here without really describing what the segment addition postulate was. So if we look at this diagram, the segment addition postulate says if point P lies between points A and C, as it does right here on this diagram, point B is between points A and C, then the distance between A and B, which we described up above that notation, plus the distance between B and C equals the distance between A and C. It's pretty intuitive. So if this point is in between these 2 points on a line, A and C, then this distance right here, AB, plus this distance, BC, equals the entire distance, AC. So using that, it says to add the measurements and figure out the missing blanks. So if I'm told that AB is 6 inches, CD is 4 inches, and AD, the entire thing, is 18 inches. I need to figure out what BC and AC are. Well, if I know this entire thing is 18 inches, and I know that this piece is 6, this piece is 4, together those pieces would add up to 10. So to figure out the missing piece in the middle, I would say, well, I know the whole thing's 18. If I subtract the 10 that I already have, I'm left with 8 inches for this piece in the middle. So BC is 8 inches. Now it's asking me what AC is. Well, use the segment addition postulate that we just learned above. AC would be this distance plus this distance, so 6 plus 8 would give me 14 for AC. Same concept, so if GM is 11, AE is 13, and EM is 9, we've got to find AM and GA. So AM, first of all, if this whole piece is 13, and this piece of that piece is 9, then to figure out the missing piece, we would take the difference. So 13 minus 9 would give me 4 inches for that other piece. So AM is 4 inches. GA, now that we know that AM is 4, GA would have to be the difference between 11 and 4. Since I know that this whole segment, GM, is 11, this segment right here, GA, would have to be 7, because 7 and 4 would add up to 11. So this was basically using the segment addition postulate backwards. Now, adding some algebra into the mix, we've got PQ is 3A minus 5, and QR is A plus 2, and we're told that the entire thing, PR, is 25. So what do we do here? Well, using the segment addition postulate, I know that this piece, PQ, plus this piece, QR, has to equal the entire thing, PR, which is 25. So I just take these expressions, 3a minus 5, add it to a plus 2. If I add those two pieces together, I should get the total of 25. So now I just combine my like terms. 3a plus a is 4a. Negative 5 plus 2 is negative 3. Equals 25. Add 3 to both sides. 28 is equal to 4a. My last step is to divide by 4. And I get that a equals 7. Now that I know a equals 7, I can take that and plug it back in to find PQ and QR. So PQ, I would plug in 3 times a, which we now know is 7, minus 5. 3 times 7 is 21, minus 5 would give me 16. And same thing for QR, plug in a 7. 7 plus 2 would give me 9 for QR. Letter D says W is between G and K. Make a diagram and write an equation relating the lengths of the segments. So if I've got point G, point K, and I've got point W between them, just using the segment addition postulate that we learned, we would have that segment GW plus segment WK would be equal to segment GK. We could also write that using the notation we described, just describing the lengths like this, without the segment symbols over it. So when two segments have the same length, this is going to come up a lot in this course. When two segments have the same length, we call them congruent segments. Congruent segments. So we use an equal symbol when we're talking about specifically lengths, so that means numbers. If we're talking about the actual segments, we use a congruent symbol. It looks like this. Basically looks like an equal symbol with a little squiggly on top. So when we're talking about the actual segments, we use the word congruent, and we use this notation. So to notate that these two segments, PQ and AB, are congruent, since we can see that they have the same length, they're both 13 inches long, to notate congruent segments on a diagram, we use what we call hash marks or tick marks. So we just make a little mark on each segment like that, going the opposite way of the segment so that we can see it. If on the same diagram you had two other segments that were congruent to each other, but not congruent to these two segments, we would use 2 tick marks on those segments to show that these two are congruent to each other, but they're not congruent to our original 2 segments. Another concept, so because point X on this diagram is precisely halfway between A and B, so the entire segment is 24 inches long, each of these segments from A to X and from X to B is 12 inches long, so that's halfway between. This is called the midpoint of segment AB. Point X is also said to bisect, that means to cut in half, so it's said to bisect segment AB. Or tick marks in the diagram to indicate that AX is congruent to XB. So a segment bisector, a midpoint is actually an example of a segment bisector. It's something that cuts a segment in half. So a segment bisector could be a point, or it could be a line, a segment, or a ray, any of those things that cuts a segment in half. So to practice, add hash marks to the diagram and find the missing values. So we lost our letters here. So T, this is T, M, H, and G. So given that M is the midpoint of TH, so these two segments will be congruent since I know that that's the midpoint, so I can put that in right away. MG, this entire thing, is 10 units long, and GH is 4 units long. First need to find MH. So since MG, this entire thing is 10, and HG, which is a piece of MG, is 4, to find the other piece, MH, I would take the difference between the total and the piece that I already have. So the difference between that would mean that MH is 6. And since we already said that this piece is congruent to this piece, TM, we know that that must also be 6. So we've got MH is 6, MT, we just said also has to be 6, and TG, now we've got to figure out the length of the entire segment. So from here to here is 6, from here to here is another 6, so that would be 12, and from here to here is another 4, so that would be 16 total for that. We could also say, well, I know this piece from here to here is 10, and this piece from here to here is 6, so 10 plus 6 would also give us 16. A couple more examples. So given that M is the midpoint of AC, AM is 4x plus 1, CM is 7x minus 20. Again, just adding in some algebra here. So since we know that M is the midpoint, I know that these two segments are congruent to each other. If they're congruent to each other, that means that they're equal. So I can take those two expressions, 4x plus 1 and 7x minus 20, and just set them equal to each other, since I know those have to give me the same number when I solve for x. So solving for x, get all my x's on one side. 7x minus 4x is 3x. Add 20 to both sides. Last step is divide by 3. X would equal 7. Same thing as before, take that 7 for x and plug it back in. So 4 times 7 plus 1 would give me 29 for AM. And now I could plug this back in. 7 times 7 minus 20, 49 minus 20 is 29. Or I could say, well, I know AM and CA are congruent to each other, like I said before, so I really don't even need to plug it in to the second equation because it should be, second expression, excuse me, because it should be congruent to that first one. Last example, given that AB is the segment bisector of PQ, the whole thing is 44, and AQ is 2y plus 4. Solve for y. So we learned before that a segment bisector cuts a segment in half. So this ray right here is cutting this segment in half. So I know that if this piece is equal to 2y plus 4, then this piece, PA, must also be equal to 2y plus 4. Because a segment bisector creates two congruent segments. So before I set these two things equal to each other and solve for the variable, but here if I do that, everything's going to cancel out and that's not going to get me anywhere. So I can't do that. However, I do know what the length of the entire segment is. So I could say, if I add the two pieces together, 2y plus 4 plus 2y plus 4, that should give me the total of 44. So if I combine my like terms, 2y and 2y gives me 4y, 4 and 4 gives me 8. Subtract my 8. 4y would equal 44 minus 8 is 36. Divide by 4. I should get y equals 9.